Alright, class, welcome to another episode of Brandon Academy. It's not really Brandon, it's actually Brandon. Oh, nope, sorry, it's actually Mr. Win today. It's going to give you a quick lesson on the law of sine, okay? Make sure you watch the other video before first, please, the intro video. Okay, so watch the intro video first, okay? Watch the intro video first. Okay, sorry for my bad writing. Okay, so let's talk about what we did before, okay? So we talked about trigonometric ratios before, right? That's when we had the sine, cosine, tangent, right? And the official definition is here. The ratios of the sides of a right triangle given a specific degree, right? And this specific degree is what we call theta sometimes, okay? The Greek letter theta for angle. But here's a crazy question. Are all of our scenarios, is everything in life used with a right triangle, right? Is everything in life always going to be like straight vertically here, right? Is every tree straight? Is every building straight? The answer to that is obviously no, right? You have the tower of, I think it's the Tower of Pisa. And then we have this crooked tree. Right, and this is me at the beach a couple weeks ago, right? A little pale, working on my tan still. So the point is, not everything is used for a right triangle, right? Things are slanted in life, right? Things aren't always vertically straight, which is why I have a new formula to solve for that. Okay, so that's the beauty of math. Okay, we can solve almost everything in life, okay? So chapter 8.6, part 1, law of sine, okay? So if you didn't title that yet, please do so. You have this formula here. It's showing all three equal signs right now, only because there's three sides. They're just letting you know that it's just interchangeable, right? You can just focus on A and B, or you can just focus on, right, sine A and sine C, just depending on how your diagram is drawn. Just a reminder, all these lowercase here represents the opposite side of the angle. So this is angle A, opposite that is side A, this is side B, side C. Okay, so just a reminder on how that works. Both of these formula work whether you put all the sides on top or all the angles on the bottom, or vice versa. It's just depending what makes your math easier. Okay, so either or, both are perfectly fine to use. Just make sure you pick the right one. Make sure you pick the easier one. Okay, which I will show you here. So again, these are probably the only handwritten notes you'll do all year. It's just a throwback. I kind of like seeing my old notes that I made. So again, hopefully you wrote down the notes for the screencast. That's the first video. So here, copy down this. You can just hit pause for me here. Right, just copy this down. This is just a very formal way to write down the formula. Okay, so please write this, hit pause. I'm gonna keep moving forward, but you hit pause and copy that down. So moving here, the law of sine can only be used to solve a triangle if you know the measures of two angles and any side. Okay, this is almost kind of common sense, right? Basically, if I give you a triangle, for example, and I said this was, I don't know, 10, 8, and 12, right? And we're trying to find angle A. When you use law of sine, that won't work. You can't solve for that because your A here would be 8. And then you don't have another angle. So basically, you just have too many missing variables to solve for this, right? And that's your B. Right? You can't have an equation with two missing variables, right? So that's why it only works when you have two angles and any side. If you recall back to chapter 4, right, this works for angle, side, right? You have two angles, angle, side, angle. I think that's it, right? That's, yep, angle, side, or angle, side, angle. This won't work if you were given three sides, right, which is this case, right? You were given three sides and no angle. You just can't complete the formula. And it won't work for a side angle side. Okay. Sometimes it would work for as. Okay, sometimes, okay? So this is what we call the ambiguous case. You can just write this down. Oops. Ambiguous. So sometimes it works for that. Don't worry about that. That's more of an algebra 2 trig issue. We will show you an example of what this looks like, but don't worry about this. Do write it down, but just know you won't be tested on it, okay? So again, if you're given a triangle, keep in mind, again, this works for any triangle, not just a right triangle. It works for any triangle as long as you're given the proper information in order to use the formula properly, okay? So let's just do an example here, okay? So if you got that written down. So write down this example. I'll do one example fully with you guys here. And then just submit your notes after this. And we'll do some of the practice problems on Monday, okay? So your only homework is just to watch the videos and complete the notes. So here, let's draw your triangle. You can just sketch it, right? No big deal if it's not perfectly accurate. Boom. Let's just call this my 80 degrees. So this has to be A. All right, just create your own triangle here. 30 degrees. B. My B opposite that is 14, right? So make sure to put the 14 there. And I'm trying to solve for A. Okay. And so just to make sure we could use our law of sine, right? Just to make sure, this is angle, angle, side, right? Do you see how we're given angle, angle, and side? So again, law of sine will only work for angle, angle, side, or angle, side, angle, okay? So from here, let's just plug it in, okay? So again, there's two formulas you can use. You can use sine A over A equals sine B over B. Or you could just use A over sine A equals B over sine B. So either proportion works. Which one would actually help us? Which one is actually easier for us to pick from? The answer would be this one over here. Okay, the reason for that is because we're trying to solve for A. And if we're trying to solve for A, it's easier the fact that A is in the numerator. Okay, this A is at the bottom, so you kind of have to switch things around, which, you know, could just complicate things. But for our case, this A is already nicely on top. So we can do that. So I have A over sine 80, which is my angle A here, equals my B, in this case B is 14, equals sine 30, okay? So in this case here, hopefully you guys are pretty comfortable with your calculators. In order to solve for A, I need to multiply both sides by sine 80. Whatever you do to one side, you do to the other. Sine 80, these will cancel out. So you're left with A equals 14 times sine 80, right? That sine 80 goes above, over sine 30. Okay. Keep in mind, don't be like, oh, the signs cancel out. Okay, that's not true. Okay, this is just one number and this is one number itself. So let's work on your calculator skills here. Hopefully you can see this. For me, I'm gonna do, there's a couple things you could do. If you're really good with your calculator, make sure you put parentheses around here. Remember, your calculator knows PEMDAS, so you need to really guide it on multiplying things properly. 14 times 80, where's my sine? Sine, close the parentheses, boom. So you're gonna take that, and then you're gonna divide it by 30 sine. Okay, 30 sine is 0.5, it equals, this should equal approximately 27.6. Okay, and that's your answer for A. okay? If for some reason you don't feel comfortable with your calculators, what you could do, right, you can just do 80 sine, okay, that's 80 sine right there, times 14. So if you don't feel comfortable with the fractions, you can just write this out, but make sure you keep 4 decimal places, okay, just to kind of be safe with it. So once you have that, you get equals, and then you're going to divide both sides by 30 sine, or not both sides, just divide by 30 sine, right? Just take 13.78, 13.7873, divided by 30 sine, and you should get the same answer, okay? So you feel like, dang, that's too much to put in my calculator at once. You could do it piece by piece. It's slightly less accurate, but as long as you probably keep 4 decimal places, I would say you'll be safe, okay? At least for my class, okay? But if you could practice putting this whole chunk into your calculator, that would be a very good skill to have. All right, y'all, good job. This assignment we'll do on Monday together, okay? Have a good rest of your day and a good weekend.